10x squared plus 16x minus 7
10x squared.
plus 16x minus 7 over 8x minus 3
Oh, this is,
plus, wait, what's up?
sorry.
Oh, keep going.
Oh,
Okay.
plus.
Yeah, plus.
All right, I was excited for a second because there's an example when we do this kind of look like that.
No, sorry.
That's all right. Can't
So
believe it.
2x squared plus 3x minus 1. And then over 3 minus 8x.
Oh, okay. This sounds.
Oh wait, now that I think about it,
You see what to do?
you get multiplied by negative 1.
Yeah. So we looked at one like this yesterday because the issue is these aren't the same, but they almost are. So I always feel bad for the student that gives this one this top and bottom. Oh my God, you know, you get cubes and shit. No. That is this. If you do what to the top and bottom? Well, how is this almost the same as that? It's offset by what? Over here, what's 3 is positive. Negative. 8x is negative. So if I multiply top and bottom by negative 1, right? Then the bottom will be the same one. All right, and then you can just combine the stuff on the top. And see how we go ahead and change all these signs. Yeah. Nate, is that right?
Yeah, I don't know why we said it. I don't.
It's a weird idea. You're not used to seeing that and thinking, oh, that's good. You gotta be careful though. I mean, if I saw this and this, it's not gonna work. Because if I multiply that by negative, the 4 becomes positive. Oh shit! So that's worse. You can't do what we just did if those are on the bottom. Maybe. They have to be completely opposite. Because then a negative 1 will make them become the same.
And that's the end of.
Oh hell no! That's the first step. But I'm trying to leave some homework for you guys to do. That got Spencer going. Do you see how? Isn't that going to make the bottom? What will the bottom become? Yeah, negative 3 plus 8x. So they'll be the same. And then once you bring the negative 1 through all that, you can just put the tops together because the bottoms are the same. Once the denominators are the same, I can add, subtract. Now, a big mistake I see people make. Which number was that, Spencer? Sorry.
159. 159.
159? Big mistake I see people make. Oh, I got and forgot it. Scheisse. You can do it, buddy. Look at you go. Look at you go. I don't know that. So something like this, I see people trying to give this LCD. Why do I not need an LCD? I only need an LCD when I'm trying to do what? Add, subtract. When I'm multiplying, dividing, it's actually the opposite of LCD. I'm trying to reduce shit, not build shit up. Right? Maybe. So when you add, subtract, you have to have exactly like terms. So like denominators are like terms. When I multiply, divide, they don't have to be exactly the same. Maybe. All right.
Can you at least,
Sorry?
I was going to say, can you at least solve the bottom one?
Oh, well, this is not going to really go anywhere.
Oh.
So what would you do to this problem? How do you divide fractions? Multiply by the reciprocal. And nothing's common, so it would just be multiply the tops, multiply the bottoms, right? All right. Okay, so there's no more questions from homework. Yes. 6 over x. Oh, I think that's, wait, 6 over x plus
2/3.
2 over 3.
Yeah. 1 over 1.
And it says to solve for y?
Yes.
Sweet. Yeah. I'm going to do this a long way and then I'll show you the short way for this specific problem. That's why I don't show you the short way because this is a very specific thing about this problem. There's a little bit of a shortcut. What what sucks about trying to solve this for y? Where is y? Uh-huh. What? Talking. What's wrong? Why is y in a bad place? No. So it's going to be a little bit harder to get by itself. So the first thing I want to do is get it out of the denominator. Right? So what am I going to multiply by? In fact, I could even just get rid of all the denominators as it won't matter. So what's the LCD? What's he need? 3 and a 1. A liar. He needs
Y.
x and a y, and he needs
3x.
3x. So now they all have the same denominator. Why am I allowed to kill them? Because it's an equation. That's why I'm allowed to multiply. It's got two sides that'll balance out. So you multiply 3xy. They all die. I like it. And use red marker too, so it looks like a red. So what do I have left? 18y, 2xy, 3x. Let's see if you guys can see where to go from here. How many y's are up there? No. But yeah, okay, I'll go with you. I'll go with you. I'll pretend like there's 2. There really is 1 if I do what with it?
GC. Get it out.
Take it out.
GC.
Right? What's left? So how do I get y by itself? What's with the y? This shit. So what do I do with that shit? Divide because it's multiplying, right? I don't want that shit. What's it doing? Multiplying. All right, let me divide by what? That shit. That shit's gone. I shouldn't have done the whole thing, but I want to. So the very first problem was your variable was one of the things that were on the denominator, in the denominator. So the first thing you do is you clear the denominators, and then you got a much more old-fashioned. There's still a little bit of weirdness. These aren't like terms, so you can't get your y's together, but you can pull a y out. So that's why I said there really is just one y that was distributed, so get that one y back out. Now let me show you the shortcut. The reason this shortcut works on this problem is, how do I make that side become y? I just flip it. So if I can combine these and make it one fraction, I have to do the same thing to both sides. So if I want to flip one side, I have to flip the other side also. Oh, that's awesome. Whatever you do to one side, you better do the other side. So if I can make this one fraction, it could flip. Right now, if I let there be 1 over all this shit, I don't want that. I don't want it. So how do I get these? What does he need? Just these two. He needs a 3. He needs a x. So we get 18 plus 2x over 3x equals 1 over y. Flip. So we get y equals 3x over 18 plus 2x. Kabam! Now, it's not always going to work that nice. I just noticed there's a 1 over y. I want to solve for y. I just got to flip that side. So if I make the other side one fraction, I can flip it too. That kind of kicks ass. If you don't think you remember that, and sometimes it's not going to work. So that's the general way you can do any problem like this. Clear the denominators, and then you can attack the leftover equation. Maybe. Isn't that kind of cool? The more you know. Okay. Anything else from homework? Okay. So what we got into last time, I can start that guy. Yeah. Yeah? Is he going? Yeah, he's going. All right, sweet. Oh, shit. All right. So we started, what do you think about this nifty little dude? I like that. I want you to put that as it. Don't do that, because then. All right, let me cover that for you. Can you do that? Because what does that want? It wants a number that multiplied by itself is negative 9. That screws up right there. Negative times negative is positive. Positive is positive is positive. So it can only handle positives on the inside. These two can't kill each other because this is kind of an implied parenthesis. It's inside the radical. This guy can go, I'm coming in there. You guys semi... Yeah, okay. So this is what you call not... Okay, I like it. What about this? I think this is the last thing we did. We did something like this. Yeah. Now, if it was square root of 16, square root of 16 is 4. If it was square root of 25, 5. Square root of 98? If it was square root of 100, 10. So square root of 98 is just under 10, but I want you to simplify this. Not give me some decimal approximation bullshit. So who remembers how to do this? Again, if you give me a decimal when I don't ask for it, if I just say simplify and you give me a decimal, all points gone.
It was like 7.5.
Barf.
Can you break it down into something that is around
Yeah.
49 and 2?
2 goes into 98 49 times. Now here's the part that I want to get into a little bit deeper today. The next thing we did was broke that up. So then it becomes, what's up?
You didn't do that?
Yes, we did. I know we did square root of
Yesterday?
50. I remember square root of 50 yesterday.
Yeah, this is
Like
what
the
got
last
you
thing we did. Little teaser. That's all right. You guys see? And I don't know if you guys remember. I did this. I really love doing this kind of thing right here. 17 divided by 11 can't be done nicely, right? But I can break 17 up into a number 11 can handle an extra shit. A number that the radical can handle an extra shit. So then I got 11 over 11 plus 6 over 11. I got 1 and 6 11. So that's another way to think about mixed numbers. So that's really fundamentally the same idea, just with different operations here. This is multiplicatively because it's roots. That's additively because it's division. Now I know that sounded weird what I just said, but multiplication is repeated addition. All right, so you can add it out. You can see the analogy, hopefully. It's a part I can do, so I do it, and a part I can't do, so guess what? I don't do it. I like it. That's the answer. Job. So sort of like having 1 and 6/11s versus 1.5, whatever the shit it is, right? I don't want the 1 point blah, blah, blah crap. All right. Because that comes from a calculator, and the calculator passes the class, has a nice life. So let's see, let's try a different one. What about this guy? That's 32. You can't, yeah, 14 times 2 is 28, but is 14 or 2 rootable? No, square root.
4 by 7.
Yeah. One way to do this kind of problem is to just start dividing by 4, 9, 16, until you, right? Because you divide by what you know you have to end up with, one of the squares. So the better you know your squares, the better, or you just start dividing 2, 3, 4, right, until you get something else. So yeah, this is going to be square root of 4 times 7. And here's that step again that I can break those up. So what's square root of 4? 2. That's amazing. That's neat. I didn't do that on purpose. Okay. 7 right. 2 right 7. I like it. So let's look a little bit deeper at this. Let me ask you a really strange question. I've never done that before. Why can I do 3 times 2? Because they have the same root, namely no root. We never had to say it that way because we were never talking about roots before. They both have the exact same root, none. So I can put them together. So what's the square root of 3 times the square root of 2? Square root of 6. In fact, let me see if you guys really get this. A whole 3 times a whole 2 makes a whole 6. So what's half a 3 times half a 2 make? Half a 6. Holy shit. So could you do this? Cube root of 3 times square root of 2. No, because what did I just say? They have to be the same root. So those you can't do. So that's why we're able to do this. We're doing that backwards. And of course, math goes both ways. Good job. Okay, maybe. All right, so I got a little handout. No, it's not like me. Okay, it's one-sided, so I don't have to worry about it. It's only this side. Let's go. Now on this sheet, I know you guys are just going to go to the problems and start going at them, but I want to show you, for example, the reason I don't show you the second method right off the bat is because this method is better, objectively. So what's the other method that's on this sheet? Well, if I take 28, and if you thought 14 times 2, you just keep going. Break it all the way down, 7 times 2 times 2. Why can't you do the square root of 3, but you can do the square root of 9? Because in the square root of 3, there's just one 3, but the square root of 9, there's 2 3s. You with me? Square roots need groups of 2 things. So what do I see groups of 2 in here? Yeah, so that could come out, and the 7 stays inside. I prefer this, because you can see exactly why 2 is outside. I always get people do this, and they put the 7 out and the 2 in. That doesn't make any damn sense. That is the very wrong answer. There's no question about why there's a 2 there, because it came from the part you could do. Not guessing, but again, there's the method. If you like it better and if you're able to do it, feel free. So go ahead and try to do those 6 problems. You can help each other out. You can ask me for help.